The higher order polynomial theorems. Students will be able to apply the fundamental theorem of algebra rational zeros test, though we're going to skip that. Remainder theorem. Factor theorem. And synthetic division to higher order polynomials. In order to graph higher order polynomials. In order to graph them. Essential question. How is long and synthetic division related to the other polynomial theorems? And graphing polynomials. The fundamental theorem of algebra. Fundamental theorem of algebra, FTA, states that f of x has a degree n and n is greater than 0, then f has at least n zeros in the complex number system. The complex number system includes both real numbers and imaginary numbers. According to the fundamental theorem of algebra, how many zeros does 2x to the fourth plus 7x cubed plus minus 4x squared minus 27x minus 18 have? Well, we can say that the degree is 4. The degree is equal to 4. So the polynomial has 4 zeros. So we have 4 zeros slash roots slash solutions. How many solutions, zeros, roots, x-intercepts does f of x to the 2x cubed plus 3x squared minus 11x minus 6 have in the complex number system? Well, the degree is 3. So we have 3 zeros, roots, solutions. The rational zeros theorem. The rational zeros theorem states that if coefficients are integers, then the possible zeros of the polynomial have the form p over q, where p is the factors of the constant and q is the factors of the leading coefficient. Now, we won't need the rational zeros theorem for Math 3, so you can X this part out. The remainder theorem. The remainder theorem states that when a polynomial f of x is divided by x minus k, the remainder f of k, the remainder is f of k. If asked to find the remainder, using the remainder theorem is faster than doing long or synthetic division. Use the remainder theorem to evaluate 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18 divided by x minus 1. F of 1, we just plug in the opposite sign of what we're subtracting from x, and then we plug that into the function. So say 2 times 1 to the fourth plus 7 times 1 to the cubed minus 4 times 1 squared minus 27 times 1 minus 18. Evaluate that, and that's going to be equal to negative 40. So let's use the remainder theorem to find the remainder for the Paul division problem. X cubed minus 2x squared plus 6x minus 6 is divided by x minus 3. So you're going to find f of opposite side of the what's being subtracted from x. You're going to find f of 3, which is going to be equal to 3 cubed minus 2 times 3 squared plus 6 times 3 minus 6. So we need to simplify. So that's going to be 3 times 3 times 3 is 27, minus 3 squared is 9, times 2 is 18, so minus 18, plus 6 times 3 is 18, plus 18, minus 6. So that positive 18 and negative 18 will cancel out, and we have 27 minus 6. So the remainder is going to be equal to The remainder is going to be equal to 21. Use the remainder theorem to find the remainder for the division problem x cubed minus 3ax minus 21 divided by x minus 7. So you take that negative 7, you switch the sign to a positive 7, so you find f of positive 7, and then you evaluate it in the function 7 squared minus 3 times 7 minus 21, so it's going to be equal to 7 squared is 49, 3 times 7 is 21, so minus 21, minus 21, so 21 minus 21 is going to be 42, so that's going to be 49 minus 42, and the result is going to be 7. So the remainder is going to be equal to 7. Circle our answers. Use the remainder theorem to evaluate the following. 3x cubed minus x minus 7. Pause the video, evaluate for yourself. Now I'm going to go over solution. 2 is equal to 3 times 2 cubed minus 2 minus 7. So that's going to be 3 times 8 minus 2 minus 7. So it's going to be 24 minus 2 minus 7, so it's going to be 22 minus 7, which is going to be equal to 15, which is equal to the remainder. The factor theorem. The factors theorem states that if x is equal to k is substituted into f of x and the remainder is 0, then x minus k is a factor of the polynomial. So for example, show that x minus 2 and x plus 3 are factors of 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. So f of 2 equals 2 times 2 to the fourth plus 7 times 2 to the third minus 4 times 2 squared minus 27 times 2 minus 18 is equal to 0, and f of 3 is going to be equal, let's say, 2 times, sorry, f of negative 3, 2 times negative 3 to the fourth plus 7 times negative 3 cubed minus 27 times negative 3 minus 18 is equal to 0. So the factor theorem is additional part to the remainder theorem. So try this one by yourself, all by yourself. No help on this one. The linear factorization theorem. Once again, the linear factorization says that the polynomial will have the same number of factors as its degrees. In other words, degrees tells you how many factors the polynomial has. So let's pause here.